We've already learned how to graph or sketch a graph of a tangent function. Cotangent, even though it's an inverse for your when you're trying to find the functions, it is not just a matter of reflecting your graph over your x-axis to get the correct graph. So you can't take your tangent function and flip that over to get your cotangent. If you notice, cotangent does have a period that is equal to pi because it goes from here at 0 all the way out to pi. So you would have an asymptote here, and there's an asymptote here. So you'd have this period that is still a distance of pi. Now our tangents, if you remember, they went through negative pi over 2 to pi over 2, and that had a period of pi also, but it's not the same period that your cotangent's on. So don't get those confused. I always remember cotangent goes from 0 to pi because cotangent, O, and 0 just kind of remind me of where they start. You still graph them basically the same way. You still have your, once you plot in your two asymptotes, you go to the middle, halfway in between, put your x-axis or your x coordinate here, and halfway in between 0 and pi over 2 is a pi over 4, but you're going to go up 1. And if you go halfway between pi over 2 and a pi, that's 3 pi over 4, then you go down 1 and put a dot, and then you draw on the smooth curve. Now your tangents were going up from left to right. Cotangents do go down from left to right. If you want to know how you go from back pi over 4 and up 1, well, if you go to the cotangent of pi over 4, and if you think of the ordered pair at pi over 4, well, at pi over 4, your ordered pair is radical 2 over 2, radical 2 over 2. So that means your cotangent, that's going to be an x over y, not a y over x. And you're just going to take radical 2 over 2 divided by radical 2 over 2, which is just 1. And you do the same thing with the cotangent of 3 pi over 4, but in this case, 3 pi over 4, your x value is negative, so you'd get a negative radical 2 over 2 divided by radical 2 over 2, which would give you a negative 1. So that's why over here at 3 pi over 4, you go down 1, draw in your smooth curve. So let's use that awesome knowledge to help us solve example 3. Here for example 3, we do have a 3 on the inside, so we are going to have to factor this 3 out because that's our b. So when we factor a 3 out of here, we have a 2, so our amplitude is going to be 2. And we're going to take a 3 out of our parentheses. Now remember, whenever you are factoring, that is like dividing. So we're actually taking a 3 out of pi over 2, which means you are multiplying the bottom by 3. So we're going to have minus pi over 6. And you can always double check your values here just by distributing back through. So 3 times x is 3x. 3 times pi over 6, well, pi over 6, the 6 and the 3 cancel to make it pi over 2. Cha-ching! We're good. So the period, remember this is from 0 to pi over b, right? As we go back to way back here, 0 comma pi over b. And so this is going to be from 0, now this is without the phase shift, so from 0 to pi over 3. So we're actually going to shrink our graph quite a bit. Instead of going out here to pi, we're actually shrinking into pi over 3 right here. However, this will have to end up be changed. So the total distance of your period is a distance of pi over 3, the distance between your asymptotes. Shrunk your stretch, actually it's stretched vertically because of your amplitude. Right, so that means we're going to have a vertical stretch. So stretched vertically. And then it's also, it's actually shrunk because the period switches shrunk horizontally. Now, is it shifted? Yes, it's going to be shifted by this amount right here, pi over 6 to the right. So what we should probably do is put our intervals up here according to pi over 6s. So this would be pi over 6, 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is a 1/2, 4 pi over 6 is a 2 pi over 3, 5 pi over 6, and we're going to run out of room. If we go backwards, this would be negative pi over 6, negative pi over 3, and so on and so on. So our period is a total distance of pi over 3, which is 2 hash marks. But it is shifted to the right of pi over 6. So normally we are between 0 to pi, but it got shrunk, so we're between 0 to pi over 3. This is where we would normally have it, from 0 to pi over 3, but it's going to be shifted to the right of pi over 6. So this asymptote that goes down through the middle is actually going to be at pi over 6. And then you're going to have a distance of 2 hash marks, which would put us over here at pi over 2. So to graph this, we choose a point in the middle, pi over 3, and then halfway in between each of these values, you would normally go halfway in between here and you'd go up 1, or you go halfway in between the two on the right and down 1, but we're actually going to be going halfway between pi over 6 and pi over 3, and we're going to go up 2, because we have an amplitude of 2, so we are actually vertically stretching this graph. Halfway between pi over 3 and pi over 2, down here negative 2, and then you draw in this nice pretty line, pretty blue line. You got a pretty blue line, boy. And there we go. Ugh. That looks great. And then you would just repeat it. You go 2 hash marks over here. Going down like this. And then you'd have a point in the middle. Halfway between these two, you go up 2. Halfway in between 2 pi over 3 and 5 pi over 6, you go down 2. So you go, and then you just repeat it both ways, going left and right. So that's how to graph a
Adam, getting to the office,
cotangent.
please. Adam, getting to the office.
Hey, thanks, Mrs. Leverance. Adam, get to the office. Or, Klein out.